Good morning, myself Mastanbi. I am from ECE department. Now I am going to discuss the subject electronic measurements and instrumentation. So before going to start this subject, we know the importance of this subject and why we are studying this subject. So let us see in our college there are different departments are there. In all departments we have some laboratories. In these laboratories we are using different types of instruments. So these instruments are used to measure the physical quantity of variables. That's why we want to know the equipment or instruments of this EMI. So let us start this subject electronic measurements and instrumentation. In this, what is measurement and what is instrument? So first we will discuss measurement. The measurements can be performed by using instruments. These instruments works on different principles. Next, what is instrument? Instrument means it is a device that can be used to measure unknown quantity or value. This is known as instrument. So these are all about measurement and instrument. So there are different applications of EMI. So the applications of EMI is it is used in all branch of engineering, in medicine and in all human day-to-day activities. So these electronic measurements and instruments are used in all branches of engineering. Means electronic instruments and mechanical instruments and electronic instruments are used for measuring velocity, temperature, pressure, resistance, capacitance, etc. So in order to measure temperature, velocity, pressure, we use mechanical instruments. In order to measure voltage, current and resistance, we use electronic instruments. Suppose we want to measure voltage, we use voltmeter. And suppose we want to measure current, we use ammeter. For measuring resistance, we use ohmmeter. So these parameters are measured by using electronic instruments. Electrical instruments are used to measure some other parameters like power, etc. So there are some advantages of electronic instruments. So the advantages of electronic instruments is it has high sensitivity, low power consumption, and it is high reliable, and less weight, easy to operate, block 1 is sensor or detector, and block 2 is transducer, and block 3 is manipulating unit, or signal conditioning unit. And last block is, it may be a recorder or indicator or controller. So these four blocks represents the block diagram of general measurement system. So first, what is the quantity we want to be measured is applied to the sensor or detector. That is, input quantity is applied to the sensor or detector. Here sensor or detector detects the input signal. Next block is transducer. Transducer means it is a device which converts one form of energy into another form. Here transducer converts the output of this sensor into electrical signal. So here transducer converts the output of this sensor signal into electrical signal. Next block is manipulating element or signal conditioning element. Manipulating element. The output of the transducer may not be suitable for further transmission. So, in order to manipulate the output of this transducer into suitable signal, we use manipulating element or signal conditioning element. The signal conditioning element includes the functions amplification, sampling, filtering. In order to amplify the output of transducer, we use amplifier. In order to filter the signal, we use filter. So, this manipulating element manipulates the output of transducer into useful form, means suitable form for further transmission. Next block is data representation block. This is data representation block. This block displays the output signal or records the output signal or controls the output signal. So this is the important general block diagram of measurement system. Next, we will discuss methods of measurement. the unknown quantity directly by comparing it with the primary or secondary standard. In direct method of measurement, we can compare the unknown quantity directly with the primary or secondary standard. For example, if we take steel bar, we want to measure this length of this bar, we can use scale or some measuring tape. So let us take steel bar. In order to measure this length of this bar, we can take either scale or measuring tape. So by this tape, we can directly measure this length of this bar. Next one is indirect method of measurement. But in direct method of measurement, this measurement has lower accuracy. So next one is indirect method of measurement. In indirect method of measurement, the unknown quantity that is to be measured is first converted into some other measurable quantity. Then we can measure this measurable quantity. So here we are measuring measurable quantity indirectly. For example, phase log loop PLL. In PLL experiment, first we will measure rewriting frequency. After we will measure log range and capture range. So this is the example for indirect method of measurement. And there are some different types of instruments are there. These instruments are electrical instruments, electronic instruments, analog instruments, and digital instruments. In analog instruments, the output can be continuously varying. So that's why analog instruments output is in continuous nature. But in digital instrument, the output is in the form of numerical form. That's why there is no chance of error. So digital instruments have high accuracy. Next, electrical and electronic instruments are used to measure physical variables like voltage, current, resistance, capacitance, etc. Next topic is performance characteristics of instruments. Instruments are mainly used to measure unknown quantities. The major problem of this measuring instrument is error. So in order to reduce resolution, sensitivity, error, and last one is expected value. So these are the static characteristics of instruments. So let us we will discuss first characteristics. Very important characteristics, that is accuracy. It is defined as the degree of closeness of measured quantity to the true value. Degree of closeness of measured quantity to the true value. This is called accuracy. Let us take an example. Suppose if the true value is 5 volts and measured value means I am taking some more measured values. More measured values are like this: 4.6, 4.7 volts and 4.8 volts, 4.9 volts. Observe these measured values. These values are not close to the true value. That's why these are not accurate. Means low accuracy. Suppose if the output of measured values like this for the input 5 volts, 4.9 volts, 4.91 volts, 4.95 volts, 4.99 volts. If here we see the last measured value 4.99 volts is very close to the true value. That's why this is has more accuracy. Next value, another accurate value is 4.95 volts and another accurate value is 4.91 volts. So compare this measured value with the true value. If error is reduced or zero, then accuracy is more. If error is reduced, then accuracy is more. From this we can say if accuracy is more, then there is low error. So this is the concept of accuracy. It is simply say that it is the ability of an instrument to show the exact reading. That is called accuracy. So the ability of an instrument to show the exact value of measurement or exact reading, that is called accuracy. This is the most important characteristics. Next we will go to next static characteristics. Resolution. The smallest change in measured value or input 1 volts. Then the corresponding output voltage is 2 volts. Next, I am applying 1.1 volts to the input. Then it gives the corresponding output 2 volts. Next, I am applying input 1.2 volts. It will give the corresponding output voltage is 2.5 volts. Next, I am applying 1.3 volts. It gives the corresponding output voltage is 2.5 volts. Next, I am further increasing to 1.4 volts. It gives the corresponding output voltage is 3 volts. Here I am justifying the definition of resolution. Here the smallest change in applied voltage that changes the output voltage. Here the change is 0.2 volts. That's why here the output voltage change is 0.5. So here we observe the change is 0.2 volts. So the output will be changed when there is a change in the input signal. That's why it is called resolution. The smallest change in input value or measured value to which the output will respond is called to which the instrument is called resolution. This is the example of resolution. Mathematically, resolution can be performed like this. Next characteristic is precision. It is the measure of repeatability or reproducibility of measurement. It is called precision. It is the measure of repeatability or reproducibility of instrument of measurement. It is called precision. Consider one example. Consider one example. Suppose if true value is 10 volts, then measured values are 9.1 volt, 9.2 volts, 9.3 volts, 9.4 volts. The 5 measured values are 9.5. Then from these values, we can say that there is low accuracy and low precision. And simply we can say that precision is the ability of an instrument to produce output signal again and again for constant input. For example, applying 10 volts to the input, it will produce measured value repeatedly 9.9, 9.9, 9.9. I am taking 4 measurable values. Then this is said to be high accuracy and value. So this is the mathematical expression for precision. That is P is equals to 1 minus xn bar by xn bar. Next, if the measurement has accuracy, it may be precise, but all the precision instruments may not be accurate. This is one important point. So, the difference between we will see the difference between accuracy and precision. Accuracy means the ability of an instrument to show the exact value or exact reading. But precision means the repeatability of reading again and again for constant output. That is called precision. For example, I am taking three instruments, ABC instruments. This is A and this is B and this is C. I am showing the relation between accuracy and precision. This is A instrument and this is B instrument and this is C instrument. Here this circle represents true value and dotted points represents measured value. These are measured values. Here we see these measured values are closer to each other. That's why they have high accuracy. But these are far away from the true value. That's why they have low precision. Here this circle represents the true value and dotted point represents the measured value. Here the dotted points are close to each other but they are far away from the true value. Then it is said to be they have high accuracy and low precision. Let us see the outputs of this instrument B. Here measured values are close to each other and these are nearer to the true value. That's why they have high accuracy and high precision. Next, we see the C instrument output. Here, the measured values are far away from each other and these are also far away from the true value. That's why they have low accuracy and low precision. This is about accuracy and precision. Next characteristic is sensitivity. This is one of the static characteristics of instrument. Sensitivity. Last important characteristic is expected value. Which value we want to decide are true value. That is called desired value is called expected value. Next, error. We already discussed there is major problem in measuring instrument. That is error. It means it is the difference between the measured value to the true value. That is called error. So mathematically it can be represented as E is equal to AM minus AT. So this is the expression for error. Here E will be positive or negative. If we add some quantity to the measured value, then we get E is equal to positive or E is equal to negative. If E is equal to positive, then AM is greater than 8. If AM is less than 80, then E becomes negative. So these are all important characteristics or performance characteristics of instrument. So first static characteristic is accuracy, means the degree of closeness of measured quantity to the true value, that is called accuracy. And the second characteristic is resolution. It is defined as the smallest change in measured value or input value to which an instrument will respond, that is called resolution. And third characteristic is precision. The ability of an instrument to reproduce reading again and again for constant input, that is called precision. And the fourth characteristic is sensitivity. It is defined as the ratio of magnitude of output signal to the magnitude of input signal. And next characteristic is error. It is the difference between the measured value minus true value, that is called error. And next characteristic is expected value. What value we are expected, that is desired value, that is called expected value. So thank you.